Alright, welcome back guys. So I'm going to do this short video on some of the support for 8.5. This is going to be on simplifying rational functions by factoring. And I want to start off, a rational function is just a fraction basically. You have a polynomial in the numerator and another polynomial in the denominator. And so you can simplify these fractions by factoring. So I'm going to give you, I want to motivate this discussion with a numerical example. So what if we had the fraction 8/12? Okay, and to simplify this, you could divide both of these numbers by 4, and that would take it down to 2/3. But really what you're doing is you're factoring both the numerator and the denominator, and you're dividing out those common factors. So for example, for 8, we can factor it 2 times 4, and then for 12, we can factor it 3 times 4. Okay, and so because 4 divided by 4 is equal to 1, this is really just like 2/3 times 1. Okay, because the 4 over 4 is the equivalent of 1, and when you multiply anything by 1 it stays the same, so this becomes 2/3. Now another way people look at this is you divide out those common factors, and this is what we refer to as removing factors of 1. Okay, and we're going to see that in these next 3 examples. So the procedure to simplify these next rational functions is going to be exactly the same. They're all fractions, and we're going to try to factor both the numerator and the denominator, and if there are any common factors, we're going to divide those out, and that's actually how we simplify these. Okay, so I wanted to do this just to give you some extra practice with factoring, because that's the big deal here. So if we look at example 1, it says simplify by removing factors of 1. Okay, so in other words, we first need to start factoring. So when you're looking at that numerator, it's 3x minus 12. The only way you can factor it, and it's a binomial by the way, the only way you can factor it is by taking out a GCF. Okay, we've talked about this a little bit, a greatest common factor. So you say, well, what do these two terms have in common? Well, they have a 3 in common. Okay, so you take a 3 out. Remember, factoring out a greatest common factor is the opposite of utilizing the distributive property. So instead of distributing a 3 to 2 terms that were already in parentheses to get this 3x minus 12, we're actually dividing out the 3. And so to see what you have left in those parentheses, you can divide each of those terms by 3. So you can see here, the 3's would divide out, and that would just leave us with an x. And then over here, negative 12 divided by 3 would give us negative 4. And so now we have the numerator factored. We've written it as a product 3 times this binomial, x minus 4. And with factoring, if you remember guys, you can always check by multiplying. So if I distribute this 3 times x will give me back the 3x, and then 3 times negative 4 gets me back the negative 12. So you can always check these. And the same thing's going to happen on the bottom. We're going to need another GCF. That's the only way you can factor that bottom binomial. And you can do it the same way. Divide by 3. So that's going to leave us with an x plus 4 in this case. And so you can see that we have a pair of 3's. Those are our common factors, or in other words, that is essentially a factor of 1. Okay, so what you can do is just divide those out, divide out those 3's, and then whatever you have left, that is the simplified function. And when all you have left is just a binomial, and there aren't any other factors up there, you don't have to keep it in parentheses. You can if you want. Okay, now number 2, same thing, except to factor these two polynomials, this binomial on top and this trinomial on bottom, we're going to have to do it a little differently, okay? So to start, this binomial on top, this is what we refer to, if you remember from your transitional algebra class, if you took that, it is a difference of squares. That's what we call it, okay? What this means is that both of these terms are basically squares. So for example, t squared is just t to the second power, or t times t. And then 16 is the same as 4 squared, or in other words, 4 times 4. And it's a different, we call it a difference because there's subtraction between those two terms. So the way you factor these is you get two binomial factors, and you just ask yourself, what do I need to get t squared? Well, I need a t times a t. And then what do I need to get a 16? And it's got to be the same number. I need a 4 times a 4, okay? And then to ensure that, you know, if you were to check these by multiplying them out, to ensure that we don't get that middle term that we typically do, we need to make sure the signs are opposite. So one is going to be positive and the other one's going to be negative. And that will also ensure that if we were to multiply or FOIL these out, that will become a negative 16, because the positive 4 times the negative 4 is negative 16. And then if you were to multiply the outer term and the inner term, you would get negative 4t and you would get positive 4t, which would cancel, and so you would just be left with a t squared minus 16. So you can check those as well. Now for the trinomial that's on the bottom, we don't have to use the AC method because there's not a number in front of the t squared. So if you remember from class, this one's similar. We need t times t to get the t squared back, but then we have to look at this constant, 16, and we have to find factors of 16 that when added together will give us this middle coefficient, which is negative 8. Well, the only two factors are going to be negative 4 and negative 4. When you multiply these two negative 4s, you get a positive 16, and when you add them together, you get a negative 8. Okay, so these are the two numbers we're going to go with. So you just plug those into your binomial factors, and that's basically it. Now, that's basically it. And so now, to simplify this, you're looking for common factors. Okay, so if you notice, we have a pair of binomials, the 2t minus 4s right here. So we can divide those out, just like up above, how we divided out those 4s. Because that's another factor of 1, basically, or a form of 1. So if we divide those out, then we'll rewrite what we have left, which is just a t plus 4 in the numerator, and then a t minus 4 in the denominator. Okay, so that would be the simplified form of that rational function. You can't divide these because the t's and the 4's are connected here through the addition on top and through the subtraction on bottom. Okay, let's do this last one. So this one's similar to the last trinomial. These are both trinomials. So we're going to factor them the same way. Okay, we need y times y to give us the y squared. And then we need to find factors of 2 that when summed will give us a negative 3. Well, they're going to have to be both negatives, guys. Negative 1 times negative 2 is positive 2. But when you combine those two negatives, you get negative 3. So those are going to be our two numerical factors. And then as far as the trinomial on bottom, it's very similar. We still need y times y. But now we need factors of negative 4 that when summed will give us a positive 3. So I'm thinking positive 4 times negative 1. So, you know, you may have to try try a few in your calculator until you find the combination that works. And so I've got everything factored, so do we see any common factors? And they don't necessarily have to be one right on top of the other one. As long as there's one in the numerator somewhere and another factor in the denominator somewhere, we can divide them out. And we actually do have a pair of binomial factors, those y minus 1s. We can divide out, and so that's going to leave us with y minus 2 over y plus 4. Okay. So I just wanted to review a little bit on the factoring because we will need it for 8.5 when we're working with those rational expressions to find things like the domain, the vertical asymptotes of some of those functions. You'll have to be able to factor to do that. Alright, so hope you find this video useful, and I'll talk to you later.